and welcome. In this tutorial, we'll be looking at this question on general equation of motion. And I read, a particle starts from rest. Its acceleration after t seconds is 1 over parenthesis 1 plus 2t raised to the power of 3 meters per second squared. Find its speed and how far it has moved after 2 seconds. Now, to solve this question, the first thing I will do is to derive the equation for the speed function using the acceleration function. Okay, and because in the question we are given that the particle starts from rest, then I will need to set my initial value condition that the initial velocity will be equals to 0 when time t is also equals to 0. That means v of 0 is when we have time t to be equals to 0. So with that, I'll be able to find the value of the constant of integration. So then once we know the constant of integration, then it means the speed. It will be easier to find the speed by plugging in the value of time when the time is 2 seconds. Okay, then also to calculate how far it has moved after 2 seconds, I'm going to use the equation for the speed function to derive the equation for the distance function. Okay, and I'm also going to do the same, it's the same process anyway. So, all right, so now we are given the acceleration function to be equals to 1 over parenthesis 1 plus 2t raised to the power of 3 meters per second squared. Acceleration is the rate of change of velocity, okay, which means acceleration can be expressed as a first derivative of velocity with respect to time. So which means acceleration as a function of time t can be expressed as dv over dt. So which means that dv over dt will be equals to 1 over parenthesis 1 plus 2t raised to the power of 3. So I'm going to what? I'm going to integrate both sides to get rid of dt. So integrating both sides. Okay, integrating both sides. So which means that in this case, I'm going to introduce the integral of dv because I want to get rid of dt on the left hand side over dt equals to the integral of 1 over parenthesis 1 plus 2t raised to the power of 3. Okay, so now if I multiply this equation by dt, okay, so it means that multiplying this by dt and also multiplying this by dt, we're going to have dt, we cancel dt in this case, so that the integral of dv will be equals to the integral of 1 over 1 plus 2t raised to the power of 3 with respect to t plus c. Of course, we can do it from here as well, multiplying through this equation by dt before introducing the integral sign. Okay, so now integral of 1 dv will be v. So which means because the time, okay, we want to derive the equation for the velocity function. So I'm going to write this to be velocity as a function of time, and that will be equals to the integral of 1 over 1 plus 2t raised to the power of 3 with respect to t plus the constant of integration. Now, to integrate 1 over parenthesis 1 plus 2t raised to the power of 3 with respect to t, I'm going to use integration by substitution. So now let me write 1 plus 2t equals to u equals to 1 plus 2t. So which means that du over dt will be equals to 2. Then dt will be equals to du over 2. So this is dt from what we have here. dt will be equals to du over 2. Now, if we have v as a function of time t equals to integral of 1 over, now 1 plus 2t is equals to u. So this will be u raised to the power of 3 with respect to t plus c. So now I can substitute du over 2 for dt, okay, so that v as a function of time t, okay, will be equals to the integral of u raised to the power of negative 3 multiplied by du over 2 plus c, so that v as a function of time t will be equals to 1/2 of the integral of u raised to the power of negative 3 du plus c. So by integrating this, if we integrate this, this will be 1/2 of u raised to the power of minus 3 plus 1 divided by minus 3 plus 1, then plus the constant of integration, which is the arbitrary constant. Now, the rule I apply in this case is that if you have integral of x raised to the power of n with respect to x, it will be x raised to the power of n plus 1 over n plus 1 plus the constant of integration. So that's the rule I apply in this case. So v as a function of time t will be negative 3 plus 1, that will be minus 2. Minus 2 multiplied by 2, that will be minus 4. So this will be minus 1 over 4, okay, multiplied by u raised to the power of negative 2 plus c. That is because minus 3 plus 1 is minus 2. Okay, so that v as a function of time t will be equals to negative 1 over 4 multiplied by 1 over 1 plus 2t raised to the power of 2, because u is equals to 1 plus 2t. U is equals to 1 plus 2t. Okay, then plus c. So now this is where I will now consider the initial value condition, because the particle starts from rest. So it means that the initial velocity will be equals to 0. Okay, now considering initial value condition, considering the initial value condition, so we have that v of 0, that is, this will be when v of 0, okay, will be equals to 0 when the time is equals to 0. So with that, we should be able to find the value of c. So which means that when this is equals to 0, okay, we're going to have minus 1 over 4, okay, multiplied by 1 over parentheses 1 plus 2 times 0, okay, raised to the power of 2 plus c. So this will be 2 times 0, that will be 0. 0 plus 1, that will be 1. 1 square, 1. So which means this will be 0 equals to minus 1 over 4 times 1 over 1. Let me just write that. So the value of c will be 1 over 4. That is when I carry this minus 1 over 4 to the left hand side. So now I'm going to put it back here so that I can have the equation for the speed function. That's the speed function equation. So this is the value of c, so that v of t will be equals to minus 1 over 4, okay, multiplied by 1 over parentheses 1 plus 2t raised to the power of 3 plus 1 over 4. So this is the velocity function. This is the equation for the speed function, okay? This is the speed function. This is the speed function. This is the speed function. Now, in the question, we are asked to find the speed after the particle has moved 2 seconds. So at t equals to 2 seconds. So which means v of 2 will be equals to minus 1 over 4. So I'm going to make substitution for t. That's 2. I'll substitute 2 for t. Okay, multiply by 1 over parentheses 1 plus 2. Okay, multiply by 2. Then close the parentheses, raised to the power of, this should be 2. Yeah, this is 2. raised to the power of 2, then plus 1 over 4, so that the velocity after the particle has moved 2 seconds can be, this should be minus 1 over 4 multiplied by 1 over, this is 1 plus 4. 2 times 2 is 4. 4 plus 1, that will be 5. So this will be 5 squared plus 1 over 4. 5 squared is 25. 25 times 4, that will be 100. So that velocity after 2 seconds can be minus 1 over 100 plus 1 over 4. So now let's simplify this. The LCM will be 100. Okay, so this will be negative 1 plus, now 100 divided by 4, that will be 25. So that velocity after 2 seconds can be equals to 24 over 100, and that will be 0.24 meters per second. So this is what we're looking for. So velocity after 2 seconds is 0.24 seconds. So this is the speed, okay, speed, or we can call it velocity, okay, after 2 seconds. That's it. Okay, so now this equation for the speed function, I'm going to use it to derive the equation for the distance function, because in the question we're asked to find how far it has moved, that is the particle, after 2 seconds. All right, let me continue from here. So now to calculate the distance moved by the particle after 2 seconds. So we're going to use the speed function equation, that is that equation there. So let me write 1 over 4 minus 1 over 4 parentheses 1 plus 2t, then raised to the power of 2. Now speed, okay, is the rate of change of distance, because this is, when we say speed is a scalar quantity. Okay, now but let's say it is velocity, then it will be the rate of change of displacement. Okay, and that will be first derivative of displacement with respect to time. So in this case, velocity and speed will be equals to the first derivative of distance with respect to time. So which means the first derivative of distance with respect to time will be equals to 1 over 4 minus 1 over 4 minus 1 over 4 parentheses 1 plus 2, okay, raised to the power of 2. So now let me multiply through this equation by dt, so that dt multiplied by ds over dt, that will be ds, okay, and then the right hand side will be parentheses 1 over 4 minus 1 over 4 parentheses 1 plus 2 t, okay, raised to the power of 2, close parentheses, then dt. So now I can integrate both sides. So integrating both sides. Integrating both sides. So this will be integral of ds will be equals to the integral of parentheses 1 over 4 minus 1 over 4 parentheses 1 plus 2t raised to the power of 2, close parentheses, dt, then plus the arbitrary constants. So integrating the right hand side and the left hand side, integrating 1 ds, that will be s. So we have our distance function, that's s. This will be equals to, integrating this, okay, I'm going to get 1 over 4t, 1 over 4t. Then let's integrate this. This will be negative 1 over 4, negative 1 over 4 multiplied by, so if we let this to be equals to u, 1 plus 1 plus 2t. If we let this to be equals to u, so it means that dt will be equals to du over 2. The same way we did the first time, okay? So that this is going to be integral of u raised to the power of minus 2, okay, then multiply by du over 2 plus the constant of integration, so that this should be s as a function of time t. This should be 1 over 4 times t minus 1 over 4. Then this should be u raised to the power of negative 2 plus 1 over negative 2 plus 1 multiplied by 1 over 2 plus c. So minus 2 plus 1 is minus 1. So that the minus will coincide with this minus to become plus. So s as a function of time t will be 1 over 4 times t, then plus 1 over 4. Okay, then we have u raised to the power of minus 1. Now, 1 over 2 times 4, that will be 8. So this is 8. Then plus c, so that the distance function will be 1 over 4 was 1t over 4 plus 1 over 8, then parentheses 1 plus 2t, okay, because u raised to the power of minus 1 is 1 over u, then plus c. So at t equals to 0, okay, at t equals to 0, so s0 will be equals to 1 over 4 parentheses, that's 1 over 4 times 0 plus 1 over 8 parentheses 1 plus 2 times 0, then plus c. So this will be 0, distance will be 0, this will be 0 plus 1 over 8, this will be 0, 8 times 1, this is 1 over 8 plus c. So that c will be equals to minus 1 over 8. So this is the arbitrary constant. Let me call this one c1. Okay, that is c1. So that the distance function will now be this 1 over 4, 1t over 4 plus 1 over 8 parentheses 1 plus 2t, then plus, okay, this is minus 1 over 8. So now at t equals to 2, so when the distance is 2 seconds, when the time is 2 seconds, so what is the distance? When the time is 2 seconds? So when the time is 2 seconds, so we have s of 2 equals to 1 over 4 multiplied by 2, okay, plus 1 over 8 parentheses 1 plus 2 multiplied by 2, then minus 1 over 8. So this would be 1/2, okay, plus, then this would be 1 over 8 parentheses 2 plus 2 times 2 is 4, 4 plus 1, that will be 5. So this would be 5 times 8. So this would be minus 1 over 8. Okay, so now the LCM of this will be 40. Yeah, because 8 times 5 is 40. So 40 divided by 2, that will be 20. 20 times 1, this will be 20. Okay, 40 divided by 40, that will be 1. Then 40 divided by 8, that will be 5. 5 multiplied by negative 1, that will be minus 5. So that this should be 21 minus 5 over 40. So the distance traveled, okay, after 2 seconds by the particle. So 21 minus 5, that will be 16. So we have 16 over 40. Dividing this by 4, this will be 4. Divide this by 4, this will be 10. And that will be 0.4 meters. So which means the distance traveled by the particle after 2 seconds is 0.4 meters. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.